The broadcast is now starting. All attendees are in listen-only mode.
Good afternoon, everybody. Thank you for attending today's third webinar on improvements to the TopSolid'Design platform for 2021. We'll get started here in just a few seconds. Give people some time to get logged in. So this webinar, we're going to cover a few topics. We're going to go over what's new in the sheet metal tools, unfolding documents, some changes to the visualization commands, and construction and other tools. And of course, we'll have open questions and answers as well. Okay, so let's get started. So what you see on the screen right now is an imported sheet metal assembly. Okay, right now it's just a bunch of dumb parts, and what we want to do is we want to recognize as much of that as sheet metal parts as we can, because maybe we want to create flat patterns for it, process it with TopSolid cut on a laser, who knows. So I'm just updating to get to the right place in my notes here. So to begin with, let's go to Tools Options. We'll talk about a new option in here, which allows you to describe the standard part thicknesses that your company works with. Okay, so in Tools Options, there's a sheet metal section. In here, you can describe the various part thicknesses that you will accept and work with. Okay, from there, when you're in the assembly document, I'm just going to simply go to the right menu, go to Sheet Metal Recognition. So it'll take a second because it's going to start analyzing all the parts in that assembly. And then I will show you how to use the new feature, Only Allowed Thickness. We'll also talk about another option called Minimum Size Allowed. And then we'll take one more sample where we talk about how to identify tubes and standard profiles. So it shouldn't take too long. Again, it's doing a lot of analysis right now. The only thickness or only allowed thickness that I just brought up under Tools Options, the whole point of that is, again, to allow you to predefine a filter of thicknesses that you want to deal with. Okay, so sheet metal recognition, here we go. So it's analyzed the entire assembly. It's found all of these different parts, right? First thing I want to do is I want to filter. I want to say stuff that is convertible as sheet metal only. And now it filters the list a bit further, right? We can click on any one of these things, come over here, it's a live preview of what that component is, and it's telling us whether it's convertible or not. Now, from here, what I want to do is I want to look for things that fall into the category of only allowed thicknesses. Again, these are the things that we specified. When I click this, the list gets smaller yet. If I go up here to edit, this brings up those same sets of defaults. Okay, we can add to them here or modify them. If I turn them off, you'll see it brings up and shows a part that's much thicker. If I click on this line item, I think that shouldn't be a sheet metal part in all reality. So using only allowed thicknesses really helps to get rid of parts that shouldn't be shown. The other option then you have is something called minimum size allowed. So if I select this and I set this at 1,000, for example, now it's going to filter and show me parts that are at 1 meter or bigger only. Okay, so like that, it's just ways to filter through to find exactly what you're looking for. Other than that, when you go to click OK, it's going to convert all of these objects found to TopSolid sheet metal parts. Okay, so that's that sample. Let's kill out of that one. And we'll go look at project number 2. This one I'm going to go ahead and convert on the fly. So we'll build a little assembly out of it. This next improvement is how to identify tubes and standard profiles. And what do I mean? So standard profiles such as this I-beam, right? Or hollow square tubing, for example. Right now, these are all imported dumb parts. If I was to make a bill of material for it, yes, it would, but it wouldn't know anything about those parts. It would just know that they exist. So the first thing that I want to do is I want to go into here, go to sheet metal recognition, and I'm going to click on Identify Tubes and Standards. And as soon as I do, what you'll notice is it is finding what it can for these standard components. So this is an H-style square extrusion, right? From there, we'll go ahead and click OK. and we'll let it convert those objects. And now that that's done, watch what happens. I'm gonna hit save, and I'm gonna go here and make a bill of material. Again, it's just an imported assembly, right? And I'm gonna go to profiles with cutting lengths here. We'll hit the little green check, and notice it's given us all of the cut lengths as well as any angles that exist on any of these objects. So imported model, we ran some automation, pulled that information together quickly so that we can get to manufacturing more quickly. Alrighty, so let's keep on looking here. Next sample is notches on sheet metal parts. So a lot of these improvements are for importing of parts and converting them to top solid sheet metal parts. So this part was imported. Okay, if I go to my history tree here, go away, whatever that is. So I'll go to my history tree here. You see that you have the, it's basically empty history. It's just an imported part. If I analyze this part, kind of look around at it, it looks like a sheet metal part, but if I look here, there's a mistake. There's no relief here. So first thing I want to do is I want to put a notch in there. So I'll go to my sheet metal tab, and you'll notice everything's grayed out except the notches command. So I can go here to notches. I'm going to select that edge right there. I can play around with the size of the notch I want, the type of the notch that I want. Maybe I want that to be 3 millimeters like so. Maybe I want to put one on that side over there also. Okay, go ahead and green check that. From here, now I'm going to run the sheet metal recognition. We'll say select that bottom face. It finds everything correctly. All the lateral faces are set correctly. Green check. It now recognizes this part as a sheet metal part. You could also use this notch command at any time. For example, maybe on this pocket here or this opening here, maybe we want to notch this. So select the edge and notice the arrow points to the side it's going to notch. I could double click on the arrow to flip to the other side. I could double click on the center ball to say symmetrically do it to either side. Double click again to go back to one side. Or if you don't like that methodology, you can always come in the dialog box here, change it to start, change it to start and end, however you want. But that's using this new improved notch command. Okay. Next, we're going to look at internal forming removal. So here I'm going to show a video. Give me 1 second here. Pop that up, drag that over. Okay, so we have a part, again, an imported part, and there's some forming features on here that we want to remove because maybe we want to remove them because we're changing them for the customer, or we want to put top solid forming features in there, who knows. So this tool allows you to identify a face followed by all the loops, and then whether or not you want to create frames or not, where those features were. The creation of frames is handy because you can use them to create other features. For example, if I was to do a drilling, I could drill right on that thing and pop a hole in there. Why not? Or I could include a top solid forming on there. Okay, you could use that drilling to do a repetition on frames then. So we know the source frame is that first frame, and then from here we can just select all the other frames. Perfect. That's internal forming removal. Now, let's go look at the next one, which is bend management. Bend management, we're going to go to the next video on. So the bend management command allows you to extract or replace bends on a part if the modeling of these parts is not perfect, for example. So the whole point here is we just want a fast way to be able to remove bend radiuses on this imported part because maybe they weren't added properly by whoever sent them to you. So we can just go start to recognize bends, and you can see how it's extending geometries. So we select the bend, it's extending it back, and it's basically like our heal command for face removal. It's just a little bit smarter because you can do it with or without the extensions. Perfect. And then from there, we can go ahead and recognize the sheet metal part. And then we can go put reliefs back in. So we'll say we want to process that face, have it put the right bend radius in, put the right reliefs in, and off you go. So again, it's just a tool to help simplify the process of importing parts and correcting things that are not designed properly. Okay, so here's another sample. Let's take a quick look at it. So we're going to start removing bends again on this imported part. You can see how that bend is kind of weird on the corner. And so here we're just trying to process it so it's designed properly. And then we can go in, recognize the sheet metal part, and then we can add the bend radiuses back in. TopSolid cleans up everything perfectly. Notice it found all the edges automatically as well. It's kind of cool. And you're done. Okay, next sample has to do with manufacturing feature recognition. So we're going to go to that video next. Like I said, I'll do some of these things I do live, some of them I just use videos. So basically here, we're trying to define manufacturing features off of sheet metal. Okay, so we just have to choose to enable this process. And again, manufacturing features are then passed to the appropriate manufacturing software. It's a way to help speed up calculations within TopSolid. That's it. Okay, so now we're going to talk about the unfolding a mirrored part command. So let's go ahead, launch that video. Okay, so we have our sheet metal part. So we want to mirror the part unfolding. So it's going to ask you first, where do you want to put this? You can make a new folder if you want. You can select an existing folder. It's up to you. It's going to ask you what the part template is you want to use. And then it creates, as a derivation, the mirrored part plus the mirrored flat. Because why not? The first one's already done, so we know all the settings to use. We're just deriving it so that you have the mirrored copy. All right. So that completes the sheet metal stuff. Let's go talk about our unfolding. Let me go find that in my list here. 2 seconds. All right, so in this one, basically there is, in the unfolding process now, it is possible to create a parameter from a bill of material, okay? So for example, here I'm showing you in this bill of material, the manufacturing index number. And on this flat pattern, we're going to go ahead and create a new parameter type so that we can pass a parameter from the bill of material into this flat pattern document so that it passes along to processing properly. Okay, so we go up here to construction parameters, parameter from a bill of material. You name it what you want. So I'm going to call this one man index, short for manufacturing index, and I'm going to pull it from the manufacturing index from the bill of material. Green check. We're going to make 2 more of these. Parameter from bill of materials. This one's just going to be quantity. Okay, and we're going to make 1 more. Oh, nope, sorry, we're just making 2, sorry. And here, we're now going to pass those parameters into the text that we have for this flat pattern. So you can see we just called it from the list. There it is. Now, we'll do the same thing down here with quantity. But what I'm showing you first is the fact that, okay, we're passing the bill of material information, but it would be better if we could help it out, give a little description. So Now we're going to add some random text in here. So we're just going to do an open quote, manufacturing index, colon, close quote. Okay. And then we're going to put an ampersand sign in. And this allows us to take text, that's what's in the quotations, plus an ID or a parameter, and create the specified text string that we're after. So we'll do this again. Let's do an open quote. We'll type the word quantity. Looks good. Put the ampersand in so that we're adding the two strings together. Go back, add a colon. Life is good. Perfect. So it's just showing you how to pass a parameter from a bill of material into a sheet metal unfolding document. Okay, so next we're going to talk about visualization. So give me 2 seconds to get into my visualization samples. Again, like always, if anyone has any questions, feel free to just type them into your screen. We'll do our best to answer them. Okay, so first visualization sample. Let's go into here. We'll open this up. Okay, so this is just some kind of assembly, right? Looks like some cabinets. And right now you can see I'm rotating freely anywhere. So one of the improvements this year is to lock the Z-axis. So if I go to my visualization tab and I go here, it's called lock vertical. If I turn this on and now I go to rotate, watch what happens. So if I go up, see how it's locking? It won't let me rotate more than 180 degrees, first of all. And then it's staying locked about that vertical axis. So that screen vertical axis, depending on where your cursor is, allows you to rotate just about the screen vertical axis. That's its whole purpose in life. Okay. Turn it off, you're back to free rotate. Okay, so the next improvement has to do with emissive environments. This is for people using TopSolid image in rendering. The rendering would take some time to do, so I'm not going to do it live here for you guys. But basically, what emissive environments allow you to do, let me pull this document over, is they allow you, when you include the environment, to choose whether it's an emissive environment or not, and whether it's activated. But the emissive environment allows the natural light of the environment to be what's lighting your rendering. Okay? Perfect. All right, let me get set back on my other screen here. That is visualization improvements. I believe next we're going to talk about some construction improvements. So let's get that set up and we will get to that section in here. All right, so the first new feature in construction has to do with parameter animation. Okay, so we'll go ahead and open up a little sample here. So here we have a sample. We go to construction. You have a new command called animate parameter. And with that command, you can choose your named parameter. It has to be named. Okay, and then you choose the parameter to animate. Choose a start value and an end value. And then how many steps you want to take to get there. Or give it a step value. You want to see an update every 1 millimeter, for example. Or you want to see 100 iterations, right? And then you can click animate. And it shows you exactly what that looks like as it goes through those incremental changes. So the whole idea here is to be able to see what those changes would do to the part progressively. So we can do the same thing with parameter, why not? Give it a start value, give it an end value. How's that for crazy? So it's just a way to test things. Okay, so a few other samples we're going to show here. So next, we see we have a simple sketch here. So we want to optimize or animate parameter A. We want to give it a point to follow as well. And then we can hit animate. And it is showing you the path that that point is going to take. Let's do some more samples. So again, this time we're going to check that. We'll go ahead and click animate. Nope. Follow that point. That's kind of crazy. So I think you get the idea. There is some pretty interesting things you can do with parameter animation. All right, let's keep on looking. Oh, I see some questions. You have to generate those parameters before animating them, or does it automatically generate them based on your dimensions? You have to at least name the parameter. The only way that you can animate a parameter is if you give it a name. And to give it a name, you just click in front of it when you're editing it. Call it, for example, if it's an angle, say A, and then the equal sign, and then whatever the value is. Can the animate parameter be used to create a sketch? Yes. There's an option there to create the sketch in your environment. So once it's done, that sketch is created back inside the environment. Okay. All right, what's next? Constrain linear pattern is next. Oh, nope, envelope block is next. So again, I'm just going to show this one this way. So we have our block envelope. Move something out of my way over here. So if we go to block envelope here, this is just to calculate some stock sizes. You can tell it to create parameters for you. And if you do, it then will show up in the parameters section here. So it just creates parameters for you automatically out of that block envelope. Okay. All right, constrained linear pattern is next. So with constrained linear pattern, I'm going to pull up a video here. You have a kind of a similar thing that we just saw in the last one. Okay, the create parameters box has been added under advanced options. Okay, and what that does for you then is that'll create a parameter for everything inside that pattern. So you see your total distance, your end margin, your start margin, your step, everything. So this way you can more easily modify any of those values. Perfect. Okay, from there, I believe we're moving on to pattern modifiers. So let's go have a look at that. So the new construction pattern modifier option allows you to define a pattern as drivable so you can delete or shift one of its instances in the assembly. So let's have a look. So if we go to pattern modifier, we can now take this pattern that's already existing, make it modifiable. So you can see now the pattern modifier exists. And now we're going to go make a family out of this. Okay, we're going to make that as an optional driver. Check it in. All right, so now let's go build an assembly. And let's go ahead and include our family. So of course we have our length, width, and thickness. And now we can edit the pattern modifier. And this is kind of cool. So we can delete it. Okay, meaning we don't want those instances there. It's cool. And remember, this is an included family member, so that's kind of neat. And then we can shift it because we want this instance some distance, either with the arrow or by value. Let's shift that one back the other way. And like that, our family member successfully deployed our pattern modifier. Okay, last point in construction has to do with point clouds. So let's have a look at that. So in our point cloud, you can see I'm in an empty assembly. Under tools, I go to the point cloud command and I'm just importing a file with the format of XYZ or the extension of XYZ. That file format is just a tab delimited file. Okay, you can see it's brought in all of those points relatively quickly. From there, I'm showing you that you can use dynamic section as a modifier so that you can see things more easily. Okay, you can go to analyze geometry and you can pick on any of these points to try to get an idea of size. You can measure between things, turn off your cut, and you can start designing around this. So for example, here you can see we have a door that we designed around this 3D scan of the actual doorway. That's it. The points are selectable. You can design away around all of that. Alrighty. So what's next on our list here? That was construction. All right, so now we're gonna go to the tools section. Let me get there real quick. Okay. So here's my beautiful part. So in the enclosing block command, you have a margins and round sections have been added to the tools enclosing box and tools enclosing cylinder command dialog boxes. So if I go to enclosing box, okay, you have down here now margins. So for example, I want to measure my stock. So my stock here would be just as such. So let's just go ahead, keep it aligned. We'll click OK once. We'll go to parameters. We'll go to stock. Oh, you know what? I think I have to hit save once. Did I turn it off? That'd be funny. Closing box. Minimal, aligned, perfect. Done. Oh, sorry, it's right there. So this is our stock sizes, right? But this is the overall length, width, and thickness of this part. So where the improvement is, and this is on both of these, you have the ability to calculate this with a margin. Maybe I want to have 2 millimeters per side always, right? So I can click OK, and now those values all went up 2 millimeters per side. So you're being more accurate with how you are calculating your stock that you need to order for this part. That's all. Alrighty, let's keep on going. Alrighty. All right, couple of options here that, or at least one important option that I don't have a video for, but I don't think we really need one either. So if you have a video card with less than 2 gigabytes of memory, there's a new option here called spare video memory. You'll see it in your tools options under display general here. It just allows you to avoid allocating too much memory to your video card. So it helps things to run more smoothly with lower end cards. Okay. You have a graphic optimization that we've done as well. So the level of acceleration for the drawing shapes option uses an acceleration feature available in the recent graphics cards. This feature can be disabled if the graphics card does not support it. Okay. So it's for modern graphics cards. It allows things to just work faster. All right. Let's go to the next thing. We'll go to drilling collisions. Alrighty. So let's go to our drilling collision command here. Where are we hiding? There we go. So the drilling collisions command has been improved and now detects the collisions between the holes and the edges of the parts. The dialog box has been simplified and the drillings and threading modes have been removed. For the threading operations, the analysis is now systematically performed on the face corresponding to the thread root. Okay? So safety margin. So we're saying we have to be at least 2 millimeters away. So right now we're under 2 millimeters away. That's why it's showing those as red. Okay. And that's that. So that is the end, I believe. Let me just double check my stuff here. Yeah, that's the end of this webinar. Does anyone have any other questions regarding the topics we went over with sheet metal unfolding, visualization, construction, or the improvement in the tools section? If not, I thank you for attending, and we'll see you guys all at 3 o'clock at the last session for TopSolid'Design, where we will be going over improvements for bill of materials, drafting, and some translator information. Until then, have a great day.